in introducing to you the one and only Dr. Brian Dixon. And Dr. Brian Dixon is going to teach us today how to keep our families safe and ourselves, of course, in challenging times. And he's going to teach us today about a beautiful science called Nutrigenomics and how this is a functional medicine of the future. So a huge big welcome, Dr. Brian Dixon. I'd like to share with you a little bit more about this incredible guy. I had the privilege of meeting him about 18 months ago now, and have been astounded every time that I've had a conversation with Dr. Brian on just seeing and listening to his knowledge about health and what it is that we can do personally in our lives every day to keep things a lot safer for us. So Dr. Brian Dixon earned his PhD in molecular and cellular biology from Oregon State University in affiliation with the Linus Pauling Institute. His research focused on the underlying biochemical mechanisms of the aging process and the therapeutic potential of R-alpha lipoic acid. Dr. Dixon went on to do his postdoctoral work at the Linus Pauling Institute, evaluating the bioavailability of lipoic acid in young and elderly adults and its role in the body, and of course with aging. He has authored scientific peer-reviewed manuscripts on topics such as cancer, antioxidants, cellular signaling, gene regulation, stress coping mechanisms, NRF2 pathway, weight management, sports nutrition, recovery following intense exercise, role of nutrition in recovery from surgery, inflammation, immunity, the aging process, and research on nutrients such as glutathione, vitamin D, and so many more. So you can see that Dr. Dixon comes with massive experience. And it is such an honor for us today to hear from this incredible man who has been in the nutritional industry now for over 10 years. In that time, he has had many roles, from managing human clinical research, product innovation, product development, health education, public speaking, social media, and content marketing. As a result of these efforts, he has been a co-inventor on no fewer than 7 filed patents related to the nutritional industry. Dr. Dixon says that nutrition has always been close to my heart. I've seen firsthand the power of proper nutrition and even individual key nutrients in helping to provide optimal health. The reason I'm so excited to be joining the LiveVantage scientific team is for one reason and one reason only: their unyielding and uncompromising commitment to creating effective science-based health products. So this is Dr. Dixon's current role at the moment. He is the Vice President of Research and Development with a beautiful nutritional company. And today, Dr. Dixon, we want to thank you for your time. We know that your schedule is crazy, and we know that we are going to hang on to every word you say. So friends, if you are on here, make sure you got a notepad, a pen, your mobile so you can take notes, because today you're going to learn a lot. Dr. Brian Dixon, I'm going to hand over to you. Thank you so much, sir.
Thank you so much. With that introduction, you make me sound really old. I don't feel very old, but I also don't want my face to scare anybody. This is what happens. We've been in coronavirus lockdown for quite a while, so hair's long, and I just figured this is kind of my coronavirus playoff beard, so I'm not shaving it until this mess is over. So I hope this finds everybody down in New Zealand, healthy and well. We're hopefully on the tail end of it here. It's a nice, beautiful evening here. I can't wait to be able to get back outside and play in it more. But no, Charlotte, thank you so much for having me on. And I'll just give me a second here to kind of switch over the tech, and I'll bring up some slides, and hopefully somebody will learn just a little bit something tonight, but I think we're going to have some fun. So Charlotte, can you see that okay?
Yes, I can, Dr. Brian.
Well, wonderful. But, like Charlotte mentioned, I want to talk about nutrigenomics and then how we can integrate this into our health. This is really, I think, a new way of thinking about nutrition. And I'm going to couch the conversation in a few different ways. And the way I want to start by doing it is by talking about disruptive innovation. And then maybe, I so love our Kiwis. Everyone is so health minded down there. I grew up on the west coast of the United States in a small state called Oregon. And, New Zealand reminds me a lot of home, both in kind of the environment. It's lush and green. There's a lot of agriculture there, but also very health-minded individuals there as well. So I've recently started a new Facebook page at Dr. Brian Dixon. And so what we really hope to do here is gather a community of like-minded individuals where we can all kind of share and learn from each other. So if you like what you hear tonight, maybe I'd encourage you to follow me and we can hopefully all learn from each other. That's the goal. But let's talk a little bit about disruptive innovation. And I think before we dive into what disruptive innovation is, I think we need a good definition. So I love definitions when it comes to defining topics. And this was the definition I found that I like the most. And it's an innovation that creates a new market and eventually disrupts an existing market. So think of a lot of these big global companies we've heard so much about, a lot of them are going out of business because of disruptive innovation. And that's because these disruptive innovations can ultimately displace even the most established market leading companies that are out there. But let's talk about a few examples. I mean, how many of us are still driving a horse and buggy? Or did the car really hurt the horse and buggy business? And Henry Ford gets credited quite a bit for inventing the car, but that's not the case. It was actually a couple of engineers out of Germany who actually invented the automobile. But Henry Ford, what he did was innovated in the process of making the car and basically was able to make cars affordable to the common person. And so think about, like I said, what cars have done to the horse and buggy business. But, we might be in the midst of another disruptive innovation, and that's electric cars or self-driving cars. So who knows, we might jump in our electric car that's just going to drive itself to wherever we want to go. And who knows, electric cars might put gasoline cars entirely out of business. What about the internet? Growing up as a kid, we had a stack of encyclopedias on my dad's office shelf. And anytime we wanted to learn something, we'd have to go to the encyclopedia. And if you're old enough to remember encyclopedias, they used to be sold by door-to-door salespeople. So they'd come, knock on your door, try to sell you encyclopedias. And just about every family had a set of encyclopedias. If you wanted to find information, that's where you went. But how many of us still do that? Think about what the internet has done to all of that. I mean, most of us just go to Wikipedia to find quick information or do a search in our favorite search engine. How about photography? So there's an interesting story with Kodak and their film business. The story goes that back in the 1970s, Kodak was actually approached with the technology to have digital photography. But do you know what they said? They said, thanks, but no thanks. If we embrace digital technology, it's going to disrupt our core film business. Well, that decision alone has literally driven Kodak out of business, at least how we know it. So another great example of a disruptive technology that's come along. Think about cellular phones. When they first came out, they were the size of maybe 2 bricks put together. Then we got flip phones. Then you could start to text on your flip phone. And again, if you're old enough to remember, you'd have to count to 3 or 4 for every letter that you wanted to put in to text your friends. But now we have the smartphone. And I think a lot of us forget when that iPhone first came out, what a disruptive innovation that was. I recently rewatched Steve Jobs' launch of the original iPhone, and he had to say the words 6 times until people fully understood that you could have an internet browser, a camera, a audio player, and a phone all wrapped up into one device. And think about how we use our smartphones today. I mean, we use them for just about everything but actually making phone calls. My brother and I joke around all the time that with these smartphones, you can literally hold in the palm of your hand the whole sum of human knowledge. So think about that power. It's absolutely amazing. How about the quote unquote gig economy? So think about what companies like Uber or Airbnb have done to the taxi and the hotel business. And I even throw direct selling into this as well. Especially in today's environment, a lot of direct selling companies actually have an inverse relationship to the economy. So when people get disrupted out of a normal day-to-day 9 to 5 job, they start to look for alternatives. And direct selling businesses do really good when the economy is in a downturn. So I put that in as another disruptive innovation. Think about even a presentation today. I'm just barely old enough to remember having to do presentations where you would actually have to take photos of your slides, and then you'd have to load them. Well, first you'd have to line them out on a light board in the order that you wanted. Then you'd have to drop them into these little film carousels. And if you remember the click, click to actually get to the next slide. Well, then came along Keynote, PowerPoint, and we could do these from our laptops or even our smartphones. But even think about how we're doing this call tonight. We're doing it over Zoom, another amazing technology. And I promise you, a lot of companies are going to embrace these digital online platforms to do business in the future. A lot of companies are moving now to a more work at home type model. But what about disruptive innovation in nutrition? Think about it. Has there really been a lot of innovation in nutrition? And my answer to that is there hasn't until relatively recently. But let me tell you a little bit more about why that is and why I say that. So if there's a few brainiacs out there, you might know the answers. I don't expect a lot of you to know this, but do you know actually when the last essential vitamins were discovered? And I'm going to put the last three up on the screen just so you can see them so I can make my point. Vitamin K was discovered in 1939, so just about 80 years ago. Then folate was discovered in 1941, and the last essential vitamin discovered was vitamin B12 in 1948, so just about 70 years ago. So if you think about that for a minute, we have literally known for the last 70 or 80 years everything the human body needs to function. And this is why I also think the nutritional space can seem a little bit gimmicky. A lot of marketing claims are out there. A lot of companies are trying to put new spins on really old information. And so this is why we see companies that are maybe touting, I don't know, mega dosing, or we look at maybe these quote unquote alternative delivery systems, so gels or patches or under the tongue types of deliveries, right? Whatever it might be, these companies are really having to come up with nothing more than just gimmicks so that they can keep looking like they're innovating in a really very actually old and archaic space. But there are a few things that are happening in nutrition. And one that I really want to focus on now is something that's been happening in about the last 10, maybe 15 years. And that innovation is called nutrigenomics. So probably a bit of a new word for some, obviously a big word, but if you break it down into its pieces, it's really quite simple. So nutri is the root for nutrition, and then genomics obviously refers to our DNA and our genes. Okay, so we really are in the midst of this nutrigenomics revolution, and I'm going to kind of end by telling you how we got here. But to really talk about nutrigenomics, we do have to understand, some relatively complex science, and I'm going to try to do my best to break it down into maybe more simple terms. But some things I want us to understand are kind of what DNA and genes are, but then especially cell signaling. So to start that conversation off around nutrigenomics and cell signaling and how that can be utilized to turn on genes, I want to really start by asking everybody a question. And it might seem like a stupid question at first, pardon the irony, but do we really need a brain to be intelligent? Is it this, 3 pound or 1.5 kilo organ sitting on top of our shoulders that really is where intelligence lies? Or might there be other places inside of our bodies where intelligence might live? So again, I love definitions. When you pull up the definition of intelligence, this is the definition. It's the ability to learn or understand things. And I think this is the definition of intelligence that most of us think of intelligence as being. It's that kid, like my brother, who's really good in school, gets really good grades. Those are the guys that we think maybe go on to be doctors or attorneys. But what's so interesting to me is actually the second part of this definition. So another definition of intelligence is the ability to deal with new or difficult situations. So I want you to keep that second part of the definition in the back of your minds as we go through the next few slides. So let's talk about a few different organisms and really who are the most successful organisms on the face of this earth. Is it humans, or are there other organisms that are maybe a little bit more successful than we are? Bacteria, it turns out, are the most successful organism on the face of this earth. And why do I say that? If we took all of the bacteria living on earth and put them on one side of the scale, and then we took all of the humans living on earth and put them on the other side of the scale, which one do you think would win? It turns out bacteria by weight far outweigh humans. Can you believe that? So how can an organism that's a single cell that clearly has no brain whatsoever actually be so successful? How are they moving around, growing, dividing, finding food when they don't have a brain? I'm an avid gardener. Some of you might know that. But think about when you put a seed in the ground. There's no right side up or wrong side down. You put a seed in the ground and the roots know to grow down and the leaves know to grow up, face the sun so they can make the energy that they need to grow and survive and thrive. Sunflowers, this is an amazing behavior. Sunflowers actually follow the sun through the course of the day, and then at night will reset themselves so they're facing the sunrise for the first thing in the morning. Yet plants clearly do not have a brain. Insects are in the same boat as bacteria. If we put all the insects on one side of a scale and humans on the other, insects still far win the weight the weight challenge. But more than that, if we just took all the ants that live on the face of the earth and put them on a scale, they would still far outweigh all humans combined. In fact, insects are considered the most biodiverse group of organisms on the face of this earth. There's around 1 million that have been identified, and it's been estimated that there's about 4 million more that are still waiting to be characterized. And at best, insects only have a very primitive brain. Fish, how do they know how to swim in schools for safeties? Again, very primitive brains. How do dogs know how to fetch? In fact, most mammals within hours, if not minutes after they're born, are able to get up and walk around. It takes humans about a year to be able to do that. So is a horse or a dog or a cat, are they smarter than we are? I don't know. Well, let's think about some examples in ourselves. I'm sure we've all been in the kitchen cooking dinner, probably cut our fingers, but does that wound eventually heal up? Yes. And it heals up not by you sitting there thinking about it, like heal, heal, heal. It just happens. And what a lot of us don't appreciate is how coordinated that wound healing process is. It's actually initiated by our immune system. So immune cells will go to the site of the wound. It will start to clean up all the dead and damaged cells. And then the skin cells surrounding the wound have to grow and divide, and they actually move and can reach out and stretch to grab the cells from the other side. And then they lock up and slowly pull that wound back together. It's an amazing, coordinated process, and it's happening outside of our conscious brain. Think of some other examples in ourselves. Think about the blood flowing through your blood vessels. Think about all those nerve impulses that are constantly running up and down those nerves. Think about your breathing. I mean, were you thinking about it until I just said it? Maybe you're digesting your lunch. It's just happening. You're not thinking about it. if you were fortunate enough today to get a workout in, are you thinking about your bones and your muscle remodeling themselves so they're building back even stronger? Or are these things just happening? So I'll ask the question again, do we actually need a brain to be intelligent? And I think quite clearly, when we look all around us in nature, there are many, many different examples of intelligence that are happening. But what do you call this thing happening? What did everything have in common that I showed you? What would you call it? Would you call it luck? Would you call it skill? Would you call it adaptation? I think maybe we're getting a little bit closer. But if you were actually going to ask me what it's called, I'd call it instinct. These cells, these bacteria, these insects, the wound healing process, they just know how to do it. But I told you, the wound healing process, for example, is not an accident. It's a highly coordinated process. So how do these cells know how to do this? And so if it's instinct, it has to live somewhere in the cell. And where would it live inside of the cell? Well, I say that instinct lives inside of our DNA and our genes. And DNA, just to clear up maybe a little bit of terminology, but if I were to reach into one of your nuclei and pull out the DNA and stretch it out on a table in front of you, it would be about 3 meters long, right? Unbelievable. 3 meters or 6 feet long. And then genes are just little segments of that massive DNA molecule that are nothing more than instructions for the cells to make stuff. Okay? So an analogy that I like with DNA and genes is one of a blueprint. So is there a lot of information on this piece of paper? Yes, absolutely. There's a ton of information, but can this piece of paper actually build the house? No. A piece of paper can't swing a hammer. It can't pour cement, right? It takes a very skilled worker to be able to read this blueprint and then direct a team of skilled workers to actually build the house. So, okay, if that's where the information is coming from inside of our DNA and genes, then who would actually be the workers inside of the cell? It's proteins. And I think more specifically, it's enzymes. So enzymes in my mind are like these little machines that are working like inside of a factory. They're what's doing all of the work. Okay, so these little tiny machines called enzymes are what's actually doing the work. But then we have to ask ourselves then, who is directing the workers? So who is the boss? Well, it turns out it's this thing called cellular signaling. And more specifically, it's highly coordinated cellular signaling. So something initiates this cellular signaling. We'll call that A. A tells B, B tells C, C tells D, and then something happens inside of the cell. Okay, very simple stepwise process. Now, up on the screen, I have an incredibly complicated chart. I'm not going to walk through this, so don't worry. We're not going to get that scientific. But I put this up on the screen to illustrate a point. Back when I was doing a lot of my molecular biology studies, I would use exactly this chart or charts just like it to figure out how the cell signaling was working. So if you think about how a lot of science is done, scientists will usually put something into us, and then they will just look to see if something happens. Okay, so input, output. But what a molecular biologist wants to understand is exactly how that signal might be moving through the cell. Okay, but as complicated as this chart might be, it's really nothing more than A, then B, then C, then D, and then some physiological event happening inside of the cell. All right, so that's how cell signaling is working and how it's working inside of the cell. But what kicks it off? What activates A? Well, there are these things on and inside of our cells called receptors. And receptors are like these little sensing molecules. They're just sitting there waiting for the right signal to come along to activate them. And I like to think of these receptors as being very similar to a lock and a key. So the lock would be like the receptor just sitting there. And then just like there's a lot of specificity to that key fitting inside of that lock, that's exactly what's happening with receptors and what they call signaling molecules. And again, this is a very highly specific, highly coordinated process. So for example, the key to my house will not unlock the front door to your house. Just like your key to your house will not unlock the front door to my house. It's because there's specificity. And these receptors and these signaling molecules that unlock the receptors are working in exactly the same way. So you can even see if I put that complicated chart back up on the screen, at the very tippy top, you can see the word receptor. Okay, so that's the sensor molecule that's just waiting for the signaling molecule, those gray circles or triangles, to come along, bind to it, activate it, and then initiate that chain of events. But another analogy that I like that's maybe even a little more simple is one of a chain of dominoes. And if you've ever seen these big domino exhibitions set up, right, they'll knock them over, they'll be in these intricate patterns, but then there's usually a grand finale. And that's like the thing that's happening inside of the cell. And in fact, I'm going to show you just a short little video of one of these domino exhibitions. But I love this still screenshot. Can you actually see all the different components of cell signaling here? Where would the receptor be? It would be like that first domino. Where would the signaling molecule be? It would be the finger on that man. And then you have A, then B, then C, then D, and then you have something that happens, okay? So think about it. One tiny little input, one domino knocking over two dominoes is going to ultimately knock over all of those dominoes. And this is also exactly the power of cell signaling. There can be signal amplification that can occur. So a tiny input can have massive consequences to a cell, to our health. So I can give you maybe some real world examples. Think about a bodybuilder, right? A bodybuilder, these huge guys that are strutting around with all of this muscle draped on their shoulders. They can inject just a little bit of testosterone and literally remodel their entire physiology so they can put on unphysiological amounts of protein and muscle. Think about women. We can give them tiny little birth control pills and we can completely remodel their reproductive physiology. A tiny input can have massive consequences. So I've got another domino exhibition here. And what this is showing is that signal amplification. So the first domino this gentleman's going to knock over weighs just a few grams. And then that last domino weighs about 50 kilograms. And again, this is the power of cellular signaling. A small input can have massive consequences. Okay? This is exactly what's coordinating cellular function. But if you think about it, what would the purpose of these cell signaling pathways be? Well, think back to that original definition of intelligence. The purpose of these cell signaling pathways is for the cell to actually react and respond to its environment, both its internal environment and then what's going on around it, and then maybe even literally our external environments. This is how single cell organisms can be so successful, because they have also these cell signaling pathways that are helping to coordinate that cellular instinct or that cellular intelligence. And it literally doesn't show you which cell, it doesn't matter which cell signaling pathway I show you, they're all working in exactly this same manner. Okay? So that's really cell signaling in a nutshell. But then how does nutrigenomics kind of fit into the equation? Well, in about 2004, 2005, into 2006, 2007, not long after the human genome had been sequenced, individuals got incredibly interested in the role that nutrition was playing on our genes. And more than that, how our genes were also affecting the food that we ate. So for me, this is the seminal work related to nutrigenomics. So the experimental question in this study was, why is dark chocolate so healthy for us? So I think a lot of us are aware that dark chocolate has some great health benefits. And in fact, it does. It has great cardiovascular health benefits. So the researchers wanted to try to understand exactly why that was. So they went into chocolate and they started pulling out all these different compounds that were there. And then there was one compound in particular that really caught their eye. But what was so interesting is that this compound was actually available in only relatively small concentrations in the chocolate. But then when they gave this compound back to humans, they also found it was very poorly absorbed. So it had really low bioavailability. But more than that, they found that when this compound entered our bodies, it was metabolized incredibly quickly and then ultimately excreted from our bodies. So how in the world could a compound that was, one, present in incredibly low concentrations that we don't absorb very well and is excreted from our bodies so quickly, how could it possibly be having these major health benefits? Well, a long research story short, what they found is that this compound from chocolate couldn't make it directly into the cells, and it never accumulated to levels where it could be acting as an antioxidant. And what they found was that this compound from chocolate was binding to one of a couple of very important receptors that would activate cell signaling pathways. And then, like the molecular biologist would, they figured out exactly how the signal is making it through the cell. And then they could even determine the exact protein that was turned on at the genetic level that was responsible for these cardiovascular health benefits. And so here you really have the birth and proof of concept that nutrigenomics can have this incredible power. And so this is exactly nutrigenomics. It's utilizing nutrients that bind to receptors that activate cell signaling pathways that turn on a number of incredibly important genes inside of our bodies. These genes, interestingly, have a number of different names. They can be called longevity genes. They can be called anti-stress genes. They can be called adaptive genes. They can be called survival genes. So just by those names alone, you can see how important that they are. But how can we actually apply this principle of nutrigenomics to human nutrition? Well, let's talk about that. So my background is in the aging process. When I was going through my graduate studies, I was working in a lab that was run by a biochemist. It was a relatively big lab for an academic laboratory. There was about, between 8 to 12 of us in there. We were split about 50-50 between molecular biologists and biochemists. And really, we were trying to ask the questions, what was changing on that cellular, molecular, and biochemical level as we aged? And so interestingly, as we would find things changing with age, we would also ask the question, could we apply different nutrients to these experiments to actually change the outcomes? And the answer turned out to be absolutely yes. And so we can apply these principles of human nutrition by, I think, talking about these different theories of aging and, some of the things that we found and others as well. The three theories of aging I'm going to couch the rest of the conversation in is one called the oxidative stress theory of aging. Then we have something called the mitochondrial theory of aging. And then lastly, we'll end with something called the sirtuin or caloric restriction theory of aging. And I'll talk about these more as we go through them. So don't worry if you don't know what these are right off the bat. So let's first talk about the oxidative or free radical theory of aging. And what this theory states, and it's actually one of the older theories of aging that's out there. It was developed or postulated in 1952, 1954 by Denham Harmond. And his hypothesis was that because we're exposed constantly, mostly from our outside environment, whether it's the air that we're breathing or maybe the food that we're eating, and we're exposed to all of these different oxidants and free radicals, it's going on to have some severe negative consequences over time. And the longer we're exposed, the more these negative consequences rear their ugly heads, and ultimately it compromises cellular function. Now, what's so interesting about this oxidative stress theory of aging, and a lot of research initially centered around dietary antioxidants and how they might be able to combat it. There was relatively recently a statement that was put out by our National Institutes of Health that when you take the sum of the scientific literature that's out there, mega doses of these antioxidants seem to have no beneficial effect on health outcomes for humans. Moreover, they don't seem to have any effect whatsoever as well on our health span or even longevity. So where a lot of researchers then have turned their focus to is what's going on inside of our bodies, and specifically what's going on inside of our DNA and our genes. And it turns out that this ability to protect ourselves against oxidants and other free radicals is so important that almost every single organism on the face of the earth has antioxidant and detoxification genes that live inside of our DNA. So researchers have went on to look at how those genes are regulated, and the most important protein that's been shown to regulate these somewhere between 200 to 300 different antioxidant and detoxification genes is a protein called NRF2. And it's an incredibly interesting molecule. It's normally bound to the membrane of the cell by a protein that's called KEAP1, and it's bound there by a really interesting chemical bond. It turns out when we're exposed to free radicals, oxidants, toxins, that it actually has a reaction with that chemical bond and it releases NRF2. And then through some cell signaling steps, what happens is NRF2 ultimately goes into the nucleus and literally flips on the switches for these very protective genes. Okay. Now, I'm going to ask you to put maybe your scientific caps on for just a minute. If you wanted to go into the laboratory and you wanted to test this, how would you design that experiment? Well, what I would do is I would look for various inputs, like what nutrients can we utilize as signaling molecules to actually flip the switch. In this case, it's NRF2. And if we can do that successfully, we can elicit a number of health benefits. Okay. So think about that. We're putting the input in, we're looking for the switch, and then what happens? And it turns out it's not science fiction. It's actually relatively easy to look at whether or not genes are turned on or turned off. And so that's exactly what we did. We looked at a combination of nutrients as they relate to NRF2. And if we could activate NRF2, we know the genes that are regulated by NRF2, and we could just simply go look to see if they were activated. And so this is exactly what we did. And so when we looked at two surrogate genes, so representatives of the entire gene families that are activated by NRF2, here we have two examples. Their names aren't incredibly important. They're complex and big, but think of them as markers for NRF2 activity. And when we did that, we found in one case a 40% increase in this gene expression. In the other NRF2 gene, we saw a 50% induction in this NRF2 gene. So why is that important? NRF2, the system works pretty well. The problem is there's a big time lag that can happen from the time NRF2 is activated until these antioxidant and detoxification genes can actually be able to do the job that they need to do in the cell. So by utilizing these nutrigenomic approaches, we can turn these things on maybe before they're needed and really kind of bring the cell to a heightened state of defense. And that's really the power of nutrigenomics. So that's the oxidative or free radical theory of aging. How about this mitochondrial theory of aging? If you're not familiar with what the mitochondria are, they are really the cell's power plants, if you will. They are literally like little nuclear reactors working inside of our cells to generate the energy that our cells need to function every second of every day. To talk a little bit more about how the mitochondria are working, this is literally where the majority of our metabolism is occurring. So if we're going to utilize the food that we eat for energy, most of that food ends up inside of the mitochondria. And what the mitochondria start doing are breaking the chemical bonds in that food. And by breaking these chemical bonds, we're releasing electrons. And then our mitochondria, it's an amazing system. Our mitochondria have then the power to harness the potential energy that's in these electrons to be able to ultimately harness them for the energy currency that we need. And you might be familiar, it's called ATP, okay? Why is all of that important? So when we're young, that system works pretty well. But even in the youngest, healthiest of mitochondria, some of those electrons kind of sneak away, and they can go on to have very deleterious effects to the mitochondria and other structures inside of the cell. And again, kind of like Denham Harmon postulated, this free radical exposure has consequences and accumulates over time. And so a lot of people actually lump the mitochondrial theory of aging in with the free radical or oxidative stress theory of aging, because we also need, again, especially antioxidant protection. But there's a protein that's been shown that not only supports mitochondrial health, but actually helps with mitochondrial turnover. So as these mitochondria become compromised, become less efficient, especially with age, we want to remove those old, bad, damaged ones, and we want to replace them with young, new, healthy ones. And the main protein that controls that happening is a protein called NRF1. And it works very similar to how NRF2 is working. So it has to be released through some cell signaling steps. It makes it into the nucleus, and it will also flip on the genes related to mitochondrial health and mitochondrial turnover. So again, if you put your science hats back on, you want to go into the laboratory and you want to test whether or not nutrients can activate this very important mitochondrial pathway, what would you do? You again would look for a number of nutrients related to activating NRF1. And that's exactly what we did. We again looked for some of these surrogate genes that are incredibly important for mitochondrial health. If you can see there on the left, one called NRF2, and scientists like to make everything as confusing as possible. So it's actually a different NRF1 than the first one we're talking about, and then another protein called PGC1 alpha. Again, names aren't so important, but we're using them as surrogates and proof of concept for this nutrigenomic approach. And so when we utilize a number of nutrients known to activate NRF1, look, we can see a 61 and a 69% increase in these genes by utilizing nothing more than nutrients. I mean, how cool is that? The last theory I want to talk about is the sirtuin theory of aging. And it, at least for a scientist, is a pretty interesting scientific story. These sirtuins are actually known as the longevity genes. And how they came to be discovered is the interesting story. So there was a geneticist that was working on yeast. So the yeast that we use to make bread or brew beer. This geneticist was doing an experiment where he was restricting the number of calories that these yeast were getting. So he would reduce the calories by around 40 to 60%. And he found that he could get around a 40 to 60% increase, in the lifespan of these yeast. Well, then scientists started moving into other experimental models, things like worms, fruit flies. They even went into mice and rats. And what they found was the same thing, that if calories were restricted by about 40 to 60%, there was this extension of lifespan. So of course, that's not enough for scientists, or especially molecular biologists. They want to know exactly how that's working. So they went in, they did a whole bunch of these molecular studies, and what they found was it was the sirtuins that were absolutely responsible for this effect of this extreme caloric restriction. So you can do some pretty clever experimental tricks where you can either remove sirtuins, so do some genetic manipulations, or you can inhibit them pharmacologically. And when they remove sirtuins from these calorically restricted organisms, they found that that extension of lifespan was completely lost. So sirtuins became very interesting to especially aging researchers. So people turn their attention then to how are these sirtuins working and what specifically are they doing inside of the cell. What is so interesting is one of the major ways that the mitochondria harness the energy of that food that we eat is by gathering those electrons on a molecule called NAD. Some of you may have heard of this molecule. NAD is really the molecule that's waiting to receive the electron so that that electron can go do its job. Why this is so interesting is sirtuins actually require NAD to work. And it's also been shown that this activity of these sirtuins decreases by about 60% as we age. So why is this absolute requirement for NAD, this energy molecule, so interesting for sirtuin activity? Well, now you have this direct link between metabolism and activation of some health mechanisms. So it turns out as we're restricting our calories, right? So there's not a lot of electrons around to be captured, the levels of NAD begin to rise. It then becomes a signaling molecule and signals to these sirtuins to get active and do their job. And if they're doing that, we can experience a number of different health benefits. So what's been shown in some of these caloric restriction calories, where we're reducing the calories by 40 to 60%, is that the activity of these sirtuin proteins actually increases by about 94%. Okay? Well, when we do similar studies with nutrients, we actually see increases in sirtuin activity. So we turned our attention to these nutrigenomic approaches and how could we nutrigenomically increase NAD levels inside of the cell. And so we started looking at the NAD biosynthetic pathway. So it turns out our cells have the ability to make NAD. Okay, so we looked at a number of enzymes that are involved in this making of NAD. So again, putting your scientific hats back on, we can look at a number of nutrients or signaling molecules that we can apply to our experimental system. We can then look for the switches. So again, these enzymes in the NAD biosynthetic pathway. And if we can do that, we can again experience a number of health benefits. And so when we did that, we looked at these two specific enzymes, the two probably most important enzymes in the NAD synthetic pathway. We find maybe you could argue a modest 11 and 12% increase in the activity of these genes. But remember, the name of the game is actually trying to activate the sirtuin family of proteins. And so when we actually go and do that and put it in context of what we see with caloric restriction of a 94% increase, we were able to show that we could get a 100% increase in the activity of these sirtuin proteins. And then just for a little bit of fun, we were curious about how some of our competitors were doing. And when we looked at some of the competitor NAD products on the marketplace, we showed that they only had about a 2% increase in sirtuin activity. And so we now know that if we can increase the activity of these sirtuin proteins, we can induce a number of different health benefits, right? Around cognitive function, around that mental and physical energy. We can help support a healthy immune response. We can also talk about a number of cardiovascular health benefits. And so this is probably exactly why when these sirtuins become activated during this caloric restriction, these animals are also experiencing these massive health benefits. And so this is how we can utilize nutrigenomics in human nutrition to help us, and especially help us age more healthily. And so this is really the approach that we take with the majority of all of the products in our product line, and especially our flagship family of products, the Protandem family of products, and why we say flip the switches, right? So flip your genetic switches so we can help make you feel better so that you can also do more. But I'm sorry if everyone's bored to death, but the story doesn't stop there. We also then asked a very interesting question. We asked, well, what happened if we utilized all of the nutrients found in these products, and then went and looked at that same gene expression? Well, this is very interesting, and we looked at what we now call the tri-synergizer as a result of these studies. So if we go back to that oxidative or free radical theory of aging, and we look at those two NRF2 genes, and if you remember, I showed you that we could increase them by 40 to 50% in just 24 hours. But what happens if we utilize the combination of all three products together? Could we have a further beneficial effect? And the answer is yes, absolutely. Not only do we see a further beneficial effect, we actually see a massive synergistic effect occurring. So when we treat them with the nutrients in the tri-synergizer, we see that gene expression bump up to 73%, or a further 82% increase in the expression. For the other NRF2 gene, we saw a massive induction of 838%, or an almost 1,600% increase in the expression of that gene. Well, what about the other one I talked about, NRF1? If you remember, I showed you 61 and 69% increase in gene expression. With the combination of those nutrients, we see an 84% increase in the expression of the first gene, or about a 40% further increase, and 118% increase in that other NRF1 gene, or about a further 71% increase. So massive effects by utilizing the combination of those three products together. And then lastly, how about those genes involved in the making of NAD? Again, if you remember, I showed you an 11 and 12% increase in those genes. But when we utilize the nutrients from all three of those products together, we see a massive, almost tenfold increase in the expression of this very important and rate-limiting enzyme in the NAD biosynthetic pathway, or an almost 1,000% increase. And for the other gene involved in NAD synthesis, we saw a 226% increase in the expression of that gene, or an almost 2,000% increase in its expression. So this is exactly how we can utilize these principles of nutrigenomics in human nutrition and help keep us as healthy for as long as absolutely possible, and how we can utilize nutrition to work through cell signaling to turn on all of these incredibly important genes related to human health. And again, why we say we flip the switch so that we can feel better and do more. And so with that, I've taken up a ton of time. I know, Charlotte, but that's really just kind of even a brief overview into just some of the science that goes into our product lines, and why I'm so proud to represent this company.
Dr. Brian Dixon, that was phenomenal. I could listen to you all day. And I've been I seriously could. I've been looking at the comments in the chats, and people are like, love this, keep going, could listen to you more, love the science. So Dr. Brian Dixon, you have such a talent at making something that is so complicated, so easy to understand. So we thank you for that, and really, really do appreciate your time.
Yeah, thank you very much, Charlotte. I appreciate that. And, thank you for having me on tonight. And especially thank you to everybody for tuning in on a Saturday afternoon. I really appreciate everybody's time. So thank you very much.
You're welcome. Thank you so much. So, friends, we are so excited to let you know that we are going to follow up with another webinar tomorrow. And this webinar is going to show you a little bit more about the history of this company. It's going to share with you a little bit more about what it is that we do and how we have just launched in New Zealand. November last year, we opened up in New Zealand. I am a testimony to flip the switch and feel better and do more. My life has never been so active. My brain has never been so clear. I am going to be 50 this year. I have overcome many of my own obstacles in terms of my own body simply by helping my body to naturally do what it is meant to do. And that is because of this beautiful science of nutrigenomics and these incredible herbal products. So join us tomorrow night. You know, the world at this stage has been turned upside down. We know it is really hard and scary for many people. Are you concerned about your income and, of course, your health? We can help you. We are launching this company right now in New Zealand. We have only just in November opened up warehouses, got it all registered in your country. Everything is above board because we are a NASDAQ traded company. So we only do things the right way. And we are bringing this opportunity to you in New Zealand and in Australia. Tomorrow, we're going to have a couple of entrepreneurs that have joined us in this business, and they are people from all walks of life, people that have never done this, people that don't know people that are scared of selling, from all walks of life. We have people that have had excellent results in the business and generating an income for their family. So join us to come and learn tomorrow. Especially, I will be sharing my story of how I found this opportunity and these incredible products 4 years ago in Australia, launched it, and today, my friend, I earn well in excess of over $500,000 a year in income because people stay on our products. These products that Dr. Brian showed you today are products that are unique. You cannot find them anywhere else. This company is the leader in nutrigenomics and biohacking. And for the first time in history, this is on your shores. It's in New Zealand. The company is 18 years old. We have sold 26 million bottles of just the one product. And finally, you have access to this. So I'm going to share with you tomorrow exactly how I have built my business. I've managed to retire my husband. Come and learn how many, many, many people in Australia and across the world are doing the same thing. On the screen, you should have a webinar link. So register there. Go to www.biohackyourtomorrow.com/booking. Register. Tell your friends, anybody that you know who may want to make a bit of extra income. Maybe right now it's 100 a week, 200 a week, maybe it's 5,000 a month. We can help you by showing you this opportunity. And then you can make a decision, of course, on whether it is for you or it's not. So share this link with your friends. Come back. You're going to be excited. You're going to hear some incredible stories from your fellow Kiwis, your fellow mates in the country that are going to be sharing with you what they are doing to change their families' futures forever. Thank you so much for joining us. We hope to see you tomorrow, same time on www.biohackyourtomorrow.com/booking. Book it in. You're going to get a link, and we'll see you tomorrow.